In the previous video, we talked about how to work with A and D and how they affect the graphs. Right now, this video is going to focus on inside the parentheses. I will give you a heads up. This is going to be a little bit more work. It's going to take a little bit practice, a little bit more practice, but just stick with it. Pause the videos, pause the video, rewatch it. Just really try. I will make up some examples where I will bring back in A and D just as a refresher, but for the first example or the first two examples, I will only work with B or C. Unlike A or D though, I'm not going to give it rules. I'm just going to do the work every single time. The work is what I'm going to be focusing on, not the rules. Not trying to see what does B do, what does C do. That's not really important right now. I just want you guys to get a general idea in order to sketch. Remember, the biggest point is to sketch. So let's go with the first example, okay? Sketch the following. G of x is equal to cosine 2 of x. Now, just so a reminder from before, let's do our amplitude or our A and then D, which gives us the midline. So amplitude is the number in the front, which we can just go ahead and put a 1 there. And then if you'd notice, there is no number there. So I'm going to go ahead and put 0 here. Okay. So we have that there. We're talking about cosine. So it's going to, since it's positive, it's going to end up looking like this. Okay. And then you know the midline is going to be there. It's 0, so that means it's the x-axis. We don't go up or down at all. And now let's talk about 2x. Okay, so we need to understand that in order to do one period or one cycle, it starts at 0 and then it goes to 2 pi. That's how long it takes to repeat. So if we were to continue this graph, it would look like this, and then over here it would be again another 2 pi, so it would be 4 pi. So what's going to happen is that the numbers inside the parentheses are going to change this right here. They're going to change how long it takes to repeat and then where it starts. So what I'm going to call it is, I'm going to call it the start and the end point. That's going to be our two things. So the start versus the end point. Okay. We start at 0 usually, right, for the parent function, and then we end at 2 pi. This is going to be the most important things. So this is what's going to end up happening. You're going to take the parentheses part, and you're going to go ahead and break it up into two equations. You're going to say, I know it usually starts at 0, and I know it usually ends at 2 pi. So this right here, these two are going to be the same equations for every single problem. You're just going to take the parentheses and set it equal to 0. That's one equation, and set it equal to 2 pi, and that's another equation. And we're going to go ahead and solve. Solve just like a regular one-step or multi-step equation where you're trying to isolate the variable. Understand that the variable is the x. Pi is just a number, right? It'll be like 2 times 3.14, whatever. It's just a number. So in order to go ahead and isolate the variable, you guys know why I draw the line there to separate left and right. I'm going to go ahead and divide by 2 because I need to isolate the variable. 2 divided by 2 is 1. And so we are left with this. 0 divided by 2 is 0. So what this means is that the start didn't change. This is my start here. It's 0. It could have changed, but for this example, it didn't. And so now let's go ahead with this one. Same thing. I'm going to go ahead and divide by 2 to isolate the variable. And then 2 divided by 2 is 1. You know, in this example, it just happened that this is also 2 divided by 2. So we end up with x is equal to 1 pi. If you really want to, you can just write that as pi. And now, something changed here because this is my new end. It's pi, where it was usually 2 pi. What this means is that you're really like squeezing it in. Instead of it taking 2 pi to complete one cycle, it's going to now take only pi. And if you notice, that's half of it. So it's like squeezing everything inside. So let's go ahead and let's see how this is going to change. Okay. Now that we already did all the grunt work, let's go ahead and let's actually try and sketch this. Okay. You really have to, think about really important parts. The midline is at 0. It's going to go 1 away in both directions. We're using the positive because it is positive 1. It's going to start at 0, and now it's going to end at pi. So let me go ahead and show you how to do that, okay? So I'm just going to write everything we know so far. A equals 1. This one is at 0. We're going to start at 0, and we are going to end at pi. Usually we would have ended at pi, and then this, just for those of you, don't forget, we're talking about cosine. So let me go ahead and let's draw an xy axis and see what happens. Okay. My midline is still at 0, so I'm going to go ahead and draw that right there. Okay, so it's going to oscillate around that. My amplitude is 1, so it's just going to go up 1 from the midline and down 1 from the midline. Up 1 from the midline and down 1 from the midline. So let's see, we use this, we use this. Cosine, we know it's going to be little v, and it's positive, so therefore it's the one that actually looks like a v. And now this is where you go ahead and you figure it out. Okay, we're going to start at 0. So these 2 points, these two are going to deal with the x-axis. If you recall, the midline is usually in the middle of our graph, and we know that cosine starts off above the midline, wherever the distance for the amplitude is going to be. So that means we start in order to get that v. Usually, right, it'll mean that we can go ahead and draw it. And remember, I kind of never cared about the x values here, but now I kind of do. So what I'm going to do is still do one entire cycle. Okay. And the only difference here is that it's going to start at 0, but now instead of ending at 2 pi, it's actually going to end at pi. Okay, and that's the only really thing that I'm going to need you to understand for this lesson. Okay, for those of you that really care about, how is it actually changing the parent function, this is what you need to understand. Usually it would go out to 2 pi. So if this is 1 pi, then 2 pi means it's going to be, another unit away. So 2 pi would be somewhere here. So technically, if I wanted to, I would go ahead and I would have to draw it like this. So let's go ahead and let's really think about what's going on here, okay? Let me see if I can remember. G of x. We called this G of x. So the green one is going to be called, yeah, that you can't really see that. So the green one is going to be called G of x because that's the graph that it's, representing. And then the blue one is going to be, I'm going to call it f of x. Okay, so f of x is the parent function. It's the one that doesn't have any transformations to it. It still is, midline is 0, amplitude is 1, period is 2 pi, and it cycles every time at 2 pi. But now g of x is where it changes. G of x is equal to cosine 2x. So the blue one is the one that we've been doing every single time. I know it looks a little off, but that's just how I drew it because it's a sketch. So what you need to understand is that it was like squeezed in. Imagine grabbing this point and then just pushing all the graph over, so that instead of it taking 2 pi spaces, it now takes only pi spaces. So if you really think about it, you'll actually have 2 cycles. So let's see, 2 green cycles is going to actually equal to 1 blue cycle, or like repetition if you want to think of it like that. So for every 1 blue that it takes to go from start to end, it's going to take the green one 2 of it. This is going a little bit advanced, but that's basically what's going on here. That's how you're basically like squeezing the graph into you're squeezing the same exact graph, but you're squeezing it in a smaller space. Parent function takes up 2 pi, but now this one is going to be only 1 pi. Okay, so that's pretty much what's going on. The first initial sketch, though, that's what you really need to understand. Okay, the whole parent function, that was just me trying to help you out on like trying to see how like make sense of it. But for right now, just understand where the start is, where the end is. Okay, so let's go ahead with the next example. I'm going to do the exact same thing. The other example, we're going to first figure out where the amplitude is going to, how the amplitude is going to change, our midline, and then finally we're going to go ahead and figure out where is the start and where is it ending. Okay, so amplitude is the number in front of sine where it's being multiplied. If you notice, there's nothing there, so we go ahead and put a 1 there. There is no plus or minus on the outside of the sign, you know, like adding or subtracting. So we're going to go ahead and put a 0 there. If you really want to, you can think of it like that. And now, to figure out the start, to figure out the end, we're going to have to set up 2 different equations. So if you recall, we just take whatever is inside x over 4, and I set that equal to 0. That's one equation, and then it'll be x over 4, and that'll equal to 2 pi. Okay, this looks bad, so I'll put it over there. And then we go ahead and we solve. Some of you, it really depends on how you're gonna solve this one here. This is the first one I'm gonna solve. You can either think about inverse operations. This 4 is dividing the x, so to do the opposite of that, you can just go ahead and multiply by 4 on both sides. You can also think about what number divided by 4 is going to give us 0, because that's what the equation sign actually means, which it's kind of obvious that it's 0, but some of us can't figure that out, and that's totally fine. So super procedural, whenever you are dividing, you could go ahead and multiply by 4. Technically, if you want to, over 1, just so you can have 2 fractions, but you don't really need that right now. So you'll end up getting 4x divided by 4, which most of you are going to skip this step, but just understand it works like this. 4 divided by 4, that's equal to 1, and that's how we get 1x, or you can just write x by itself. 4 times 0, if you want to do it in fraction form, you know, it's up to you. 4 times 0 is 4. 4 times 0 is 0 over 1. Some of us still having a little bit of trouble with this. Plug it into a calculator. 0 divided by 1 is 0. If you want to keep writing that 1, you can. I'm just going to go ahead and say x is equal to 0. So this is my start at 0. Now I do the exact same thing for this other one. I'm going to multiply by 4 over 1. It's really nice because these 2 equations, you're going to basically solve them the exact same way. They're just going to be, different on this other side, on the right-hand side. So then this is going to cancel out. We're left with x. Now, this is why some of you, I would suggest, maybe you don't want to make it into a fraction if this other side is not a fraction, but I mean, if you want to, you can put that over 1. 4 times 2 is 8, and then the pi, you just bring it. 1 times 1 is 1. 8 pi divided by 1 is 8 pi. So x is equal to 8 pi. This would be considered my ending. And so let's just think about these 2 numbers, because this is what you really need to understand, okay? The parent function. So parent function, okay, that's what I'm going to call it, PF, usually starts at 0, it does start at 0, which, okay, it matches, all right, so that means that didn't change. And now the parent function usually ends at 2 pi, okay? So that's what's happening here. The parent function usually ends at 2 pi, but now it's ending at 8 pi. So this is where you have to think about, is it being squeezed or is it being super stretched out? If you usually end at 2 pi, but now you're ending instead at 8 pi, that just means you went further away from the origin. And so that means you're being super stretched out. So let me go ahead and graph this, and just so you can see how this works. Okay, so we know that A is equal to 1, D is equal to 0. We have the start at 0, and then we have the end at 8 pi. Okay, so, and then we know this is, I already forgot what it was, sine. Okay, so we are talking about graphing sine. Okay, it is a positive 1 in the front, so that means it won't change. That's how it's going to look, just like the parent function with the midline in the middle. So let's draw this x, y axis. Well, I said it the other way, but you get it, the y x axis. Okay, so we know the start is 0. So that right there is really important. Okay, that means it did not move. It did not move the starting position. We know this one is the midline. So let's go ahead and let's draw the midline right there. And then the amplitude is 1, meaning all it's going to do is go up 1 and down 1 from the midline. It happens to be 1 and negative 1 because the midline was 0 to begin with. So let me put 0 right there. And now it is sine, and we know that the sine, the first point, is right there on the midline. So that's what I'm going to go ahead and do. I'm going to draw the first point on the midline. It's positive, so I don't have to, take the opposite of it. It's going to go ahead and go up and then, reach the peak, come back down, cross the midline, go to the bottom, and then finish. So what I'm going to go ahead and do is I'm actually going to label my x-axis, and I'm going to go by pi. So I'm going to go 1 pi, then 2 pi, then 3 pi. You get the point. So this is 1, this is 2, 5, 6, 7, 8 pi. Okay, so this is going by pi's. All right. So right now, this is going to be a super rough sketch. I am not going to think about, where does it cross the middle? It's like my other points. The only points that I really am interested is the 5 points to try to give me a rough sketch. So let me go ahead and let me do this as best as I can. So it'll look something like this. Like that. Okay. Super rough sketch, but there you go. Don't really think about it, okay? Just remember the 0 and the 8 pi. That's what I'm looking for. And now let me explain how does this work, comparing it to the parent function. We know the parent function starts at 0 and it ends at 2 pi. So technically, if I were to draw it, that blue one there, so let's go back to the names. Remember, this is why it's so important. So I called this one, if you notice, I called this one Y. So I know not to use that same name for the blue one. So we're going to call this one Y. For the blue one, let's call it G. Okay? So we know that G is the parent function, and we know that Y is the new function. So if you see, we're literally taking this point, sorry, I should use a different one. We're taking this point and we are stretching it out into 8 pi. So it's basically like the opposite of the previous example. The previous example, we squeezed it in, right? What usually took 2 pi, we made it into 1 pi. But now, what usually takes 2 pi, we stretched it out into 8 pi. This is super important when we're talking about like frequencies. You're really going to be using this idea when you get to like physics, which is actually really cool. So just really understand that we went ahead and we just stretched out, we elongated the period. We made it way longer. Okay, so let's go ahead to the next example, and I want to say that in the next example, there you go. Okay, so that's pretty much the exact same thing, right? I'm going to go ahead and you notice that the 1 is there. There is no midline, so it's, there is a midline, sorry. There is no number that represents a midline, so we can go ahead and do plus 0, and there you go. So now let's do our two equations. I'm going to go ahead and start going just a little bit faster. Notice how now we're using theta, which if you don't like it, just write it as x if you want. But that just means you have to change your name into f of x. It's completely up to you. Sometimes you want to use radians, sometimes you want to use x, sometimes you want to use degrees. It's completely up to the problem. So let me go ahead and let's solve it. I know that the 5 pi looks a little bit weird. You usually have seen stuff next to the theta or next to the x. You have to just think about this is our variable. Theta is the variable, so we need to isolate it. Meaning I need to get rid of this 5 pi by moving it to the other side and by trying to get it equal to 0 right here on the left. So this becomes 0 because negative 5 pi plus 5 pi is 0. So we basically in one step already have our variable isolated. 0 plus 5 pi, that's going to equal to 5 pi. So this is technically considered my starting point. And now we go ahead and we do the same work for the next one, which I just noticed it's not supposed to be 0. It is supposed to be 2 pi. Sorry about that. And so we can go ahead and same exact steps, plus 5 pi on both sides. We end up getting, these two are considered like terms because they both have pi, so we can combine them. Since both of them are positive, we just add the coefficients, so we end up getting 7 pi. That means this is our end. Now, one really important thing to notice is, look at the start. It's 5 pi now. That means it's no longer 0. Remember, all I'm trying to get you to draw or to sketch every single time is one cycle of it. And if this work, takes you out to a number other than 0, that is fine. It might actually start at 0 at some point or cross 0, but for right now, you just need to graph this part right here. So let's think about this. This one is cosine, so it's the little v. So let me go ahead and let's do this here. A was equal to 1. The midline was 0. It did not move. The start was 5 pi. And then the end was 7 pi. We are working with cosine. So notice how my x-axis is really long because I'm going to have to go out, 5 and 7. So let me do my midline first because that's always what I do. It's 0, so we go ahead. Boom. Amplitude is equal to 1, so that means it's going to go 1 away in both directions, on top and the bottom. It is cosine, and it is positive, so that means it's going to end up looking like a V. And now finally, to draw our first point, right, to draw this one right here, it's going to be at 5 pi. So let me go ahead and let me do that. 1, 2, 3, 4, 5. So this is 5 pi. And this is 7 pi, okay? I know that, when you get to more, I guess, more difficult classes where they actually ask for these other numbers in the middle right here. But for right now, it's just, I just need you to understand how to do the start and the end and how to visualize it. So if we go ahead and we want to start graphing this, I know that it's going to start above the midline, okay, above the midline, and it's going to be at 5 pi. So at 5 pi, it's going to be above it, and it's going to be at 1. And then it's going to end at 7 pi, again at 1. And all I have to do now is connect my dots while still trying to do, the V. And so there you go. If you noticed the distance between these two, it's 2 pi, so you're technically not squeezing or stretching it out like the other one. You're really just sort of shifting. This is what is called the phase shift. You're shifting left and right here. So if you really want to think about it, right, we can consider this to be a phase shift. This is from the other videos you guys have done. Phase shift is moving either left or right. Since it usually starts at 0, but now it went to 5 pi, you're technically moving to the right, and you're moving 5 pi to the right. So that's what a phase shift would look like. All the other examples we've done, the start was always at 0, and so therefore it didn't have a shift. And so this is how you would graph that example. Let's go ahead to the next one. This is going to be really interesting because if you look at the parentheses, it is way more complicated. So let's go ahead, same thing as before, set up my two equations. X over 2 minus 3 pi equals to 0. And I won't do a mistake on this one. That's equal to 2 pi. That's a little minus sign, okay? So what I can go ahead and do is solve, adding 3 pi on both sides. This just comes from you knowing how to solve, multi-step equations. That's equal to 0 because they are inverses. X over 2 is equal to 3 pi. And then because 0 plus 3 pi is that, to get rid of that 2, we can go ahead and multiply by 2 on both sides. That'll cancel out to 1, and so we're left with x is equal to 6 pi. To go ahead and do this other one, we'll do the exact same thing. Add 3 pi on both sides. That'll give us 0. X over 2 is equal to 5 pi. And then we go ahead and multiply by 2. That cancels out. X is equal to 10 pi. So this is my start. And then this is my end. Notice two things. Since it's starting at 6 pi, that means, and it's positive, that means you are shifting to the right. Okay, so this is our phase shift. So there you go. That's the start, that's the end. Let's go ahead and really quickly do the other ones. A is equal to 1 because there's a 1 in the front. If you notice, there's no plus or minus something on the outside. So we can go ahead and do 0, and that'll be our midline. And let's go ahead and we have enough information to graph now. Okay. So we have A is equal to 1, D is equal to 0. We can go ahead and do it starts, and then it ends. And I don't remember. So 6 and 10 pi, and we're talking about sine. Okay. So we have 6 and we have 10 pi, and we're talking about sine. So here we go. Really think about these two right here. If it starts at 6 pi and it ends at 10 pi, one cycle means it takes 4 pi. So basically it takes 4 pi to complete one entire cycle. The parent function takes 2 pi, so that means you're stretching it out. So now you're basically combining everything that we've been going through right now. So the midline is at 0. That takes care of that one. The amplitude is at 1, so that means it'll only either go up one away from the midline, or it'll also just go one away from the midline, going in the bottom direction. And so now I'm going to go ahead and do a quick sketch. We're talking about sine, so we know sine looks like that. It starts at the midline and then it ends at the midline. It goes out to 6. So 1, 2, 3, 4, 5, 6 pi. 7, 8, 9, 10 pi. Which is this one. Okay. So then let's see. It starts at the midline. So I'm going to go ahead and draw that point first. And then it ends at the midline. So I'm going to draw that one next. And then let's go ahead and let me try and do my best. It'll look something. Yeah, it didn't even reach it. So let me try one more time. Okay, boom. It's super not accurate right here in the middle, but for right now, not really important. I'm not going to talk about that. That'll be, if you want to get way more complicated, that'll be another video. So there you go. Let's go ahead and let's just think about one that we haven't really, phase shift. So the start is at 6 pi. That means it moved to the right 6 pi. So there you go. Okay. That's how you do phase shift. If we think about it now, the period, it's going to take, if it starts at 6 and it ends at 10 pi, that means it takes 4 pi to basically repeat. So this is the period. It takes 4 pi to repeat. Usually for the parent function, it was 2 pi. So therefore, you know that it was stretched out. Actually, let's do this one. But the only thing that I'm going to do is I'm going to change it to a plus sign right there in the middle. Okay. So let's go ahead. I'm just going to write it so you can see it better. It'll be f of x is equal to cosine 2. Ooh, look at that. I should put an x there, not a theta. So that's wrong. Plus 3 pi over 2. Okay, so this right here is my equation, not the one on top. All right, so let's go ahead and let's graph it. And the reason why I wanted to do this one is because it's going to change. The phase shift is going to be actually a little bit different. So let's go ahead, pause the video, try to do it by yourself. If you're already go ahead and tried, let's do this here. Plus 3 pi over 2 is equal to 0. That's my first equation. And now my second equation is just going to be, you know, the other one with 2 pi instead. So 2x plus 3 pi over 2 equals 2 pi. Okay, so let's actually try to solve this. We can do minus 3 pi over 2 because that's all we're doing. We're just trying to isolate the variable. We get 2x is equal to negative 3 pi over 2. And then this is where I want to say some of you guys are going to just get stuck. So we're dividing by 2. And now what does it even mean here to divide by 2? Okay, since we have a fraction already. We already did this before. What you're going to go ahead and do is the keep, change, flip. So we're going to keep the first fraction, change from division to multiplication, and then flip this. Since it's a 2, it's now going to become a 1/2. This is just how you divide fractions. If you need to, go ahead and, Google or YouTube another video to see how that helps you. So it'll be negative 3 pi over 4. So this right here is going to be my start. Now I know that I need way more space for this one. So let me go ahead and move it. Okay. So I'm going to just rewrite it for those of us that need it. So we have 2x minus 3 pi over 2 is equal to 2 pi. Sorry, that was a plus sign. And so then we're going to go ahead and subtract 3 pi over 2. Subtract 3 pi over 2. And yeah, this is why I wanted to go over this example. Okay, so I'm going to go ahead and pick up a different color here. So it'll be 2 pi minus 3 pi over 2. The only reason why this problem is difficult is because it's throwing fractions at you. I know some of you are probably going to become super stressed out because of that, but understand that you know how to do this. It's just probably, it's been a while. So I'm going to go ahead and change that to a fraction because when we work with fractions, subtracting, that's what we need. I'm going to do times 2 times 2 so I can get a common denominator of 2. So that becomes a 2 and that becomes 4 pi because it's 2 times 2. So now we have common denominators. I can go ahead and just go ahead and subtract. 4 pi minus 3 pi is equal to 1 pi over 2. And then we just go ahead and bring down our little 2x equal sign. So now we go ahead and we have this one. I'm going to go ahead and write the equation over here. It'll be 2x is equal to 1 pi over 2. And then we divide by 2 on both sides. And this is exactly why I say, look at this problem. It's a beast, but everything that we're doing so far, you should be able to do from previous lessons. So that'll be times 1/2, keep, change, flip. And then we get 1 pi over 4. And we know this is the end. So, wow. Let's go ahead and let's slow it down. Let's think about what's going on here. The start is negative 3 pi over 4. So this is where it starts. And then the end is 1 pi over 4. Think about why that makes sense. You're starting at a negative and then you're ending at a positive. Okay? You're basically moving to the left now. So let's go ahead and try and graph it. it starts at negative 3 pi over 4. It ends at 1 pi over 4. And we're talking about cosine. Everything is 1 and the midline is 0. Okay, so let's go ahead and let's draw it right over here because it didn't let me go any less than that. So notice how I'm being smart about my xy axis. I knew the start was negative 3 pi over 4, and I knew the ending was, I already forgot, I'm not gonna lie, was 1 pi over 4. So that means it's gonna hover around the origin a little bit. So let's see, we're working with a equals 1, because I saw that. We're working with the midline still being 0. We're working with the start being negative 3 pi over 4, and we're working with the end being 1 pi over 4. Okay? This is where we're going to go ahead and just do super rough sketches. And I already forgot, it's cosine. Okay, so let's do cosine. Okay, so we remember cosine looks like that. All right, so midline is at 0. There you go. The amplitude is 1. So it's going to go up 1 and it's going to go down 1 away. It's going to be at negative 3 pi over 4, which at this point, yeah, we're just going to super rough sketch it. So we're going to say negative 3 pi over 4 is here because, you know, I'm not going to get into how to actually do it and stuff. That's not the point. And then 1 pi over 4, since it's positive, it's going to be somewhere right here. 1 pi over 4. And then last thing to do is just, you know, do my little dots. Just remember that the midline is in the middle. Okay, so dot right there. It's a positive cosine, so we don't switch. So then it'll go here, and it'll end right there. And then all I'm going to do is at least try to get it to go down to negative 1, though, you know. Boom. Bigger dot, so there you go. Okay? So let's go ahead and just think about phase shift. Phase shift. So if you notice, the start is at a negative number now. So that means we go to the left, 3 pi over 4. By saying left, by doing my arrow going to the left, I already included the negative sign. So you don't say you go left, negative 3 pi over 4. That's a double negative, so it becomes positive. So you only go left, that takes care of the negative, and then you write your thing. So that right there. And then the period, yeah, no, we're not going to talk about that right now. Just understand that that's the phase shift there. Okay? So that is the last example I want to do where I work on the inside parentheses part only. Okay? So just really think about this here, okay? To work with the inside the parentheses, we form two equations. Equal to 0 and then equal to 2 pi. And we just basically bring down whatever is inside the parentheses. You don't have to write the parentheses. I'm just writing it now just so you can understand that.